Hi, everyone. My name is Enrico, and I'm a junior scientist at CMCC, the Euro-Mediterranean Center of Climate Change. The presentation of today is about a workflow to estimate more than a century of weather and climate-dependent power supply and demand time series. So why do we need this time series? We're going to have a larger shares of power supply from variable renewable sources, and also the electrification of end uses such as heating. And this will lead to power systems that are increasingly more reliant and dependent on weather and climate. And this will in turn lead to a need for long time series at high spatial and temporal resolution. And so here I'm presenting the workflow to estimate this time series. So we start from meteorological variables such as wind speed, solar radiation, temperature, runoff. From two data sets, the ERA 5 analysis data from 1940 to 2022 or present day, and some climate models, projection from climate models from the Eurocordex initiative from 2010 to 2100, and also using some different emission scenarios. And we also retrieve some other geospatial data from such as population density, terrain roughness, terrain elevation, protected areas, and land use. So we process this data, we retrieve this data, we extract them, and also we perform a reading of the climate data projections to make them consistent with the analysis data. And then we perform a conversion aggregation. So first we convert the meteorological variables to power supply and demand time series using tools such as Light or methods from the established literature. We perform an aggregation, for example, by considering the grid cells with the top 25 best resources for wind and solar. And we use drainage basins for hydropower or population density for heating and cooling demand. And then also we perform a calibration with publicly available data from NTSOE or Eurostat. And so we end up with the country-level time series of capacity factor of offshore wind, onshore, solar photovoltaics, and then hydropower inflow, heating demand, and cooling demand. And note here the reduction in data volume from about 3 terabytes to about 25 gigabytes, which is a reduction of 100 times, roughly. And this is for just for Europe only, for all European countries. And so here is an example of this time series. You can see solar, wind, hydropower, and the heating and cooling demands, and with the typical seasonal patterns. And here, this is an example of for 1 year and one country only, but we have data for like, as I said, more than a century of data in all the European countries. And so how can we use this data, and how can you use this data? So for example, we can evaluate the impact of climate change on supply and demand. We can evaluate the resource adequacy or the ability of the power supply with large share of renewable energy to meet a variable electricity demand, and also the role of hydropower in a changing climate. And we can also evaluate the system robustness to extreme weather, different weather years, and mitigation scenarios. And with that, thank you for your attention, and I'd be happy to chat later if you have questions or want to hear more information. Thank you.